Companies that design furniture for elementary school classrooms produce a variety of sizes for kids at different ages. Suppose heights of third grade children are distributed uniformly from 44.1 inches to 60.2 inches. Number 1. What percentage of third grade children would you expect to be less than 4 feet tall? 4 feet tall is 48 inches. We have a uniform distribution with a minimum of 44.1 and a maximum of 60.2. So we're looking at U 44.1, 60.2, and we can sketch a graph of that as soon as we find the width. 60.2 minus 44.1 is going to be 16.1. So, to answer this question, we should have a graph. Again, 4 feet tall, that's 48 inches. So when we sketch the graph, we'll have 44.1 here, 60.2 here. The height will be 1 over 16.1, and we want how many people we would expect to be less than 4 feet tall. So we need 48 inches. That's somewhere around here, let's say. So that's 48. And the expectation is that this area gives the percentage or the probability that a randomly chosen student from this class is less than 4 feet tall. So the percentage is the area turned into a percentage. So the area here is 48 minus 44.1, that's the width, times the height, 1 over 16.1, which we can calculate. 48 minus 44.1, that's 3.9 over 16.1. So 3.9 over 16.1 on the calculator, you get about approximately 0.2422. Number 2. In what interval of heights should the company expect to find the middle 80% of third graders? Okay, so the middle 80%, we have still the same graph, so I'll draw it one more time here. We have the graph goes from, again, 44.1 to 60.2 at a height of 1 over 16.1. Now the middle 80% means 80% of the area located in the middle, that is, same amount of area to the right as to the left of our area. So if I try to shade in 80%, we'll say that that's 80% of the total area here. Let's say that's 80%. And notice I put it in the middle, so we have the same amount here as we do here. And since the whole thing is 100%, of course, that means we have 10% here and 10% here. So the question is, what are these two numbers here? So let's call them x and y. X and y, and we'll find these two by doing something very similar to this. We can find those numbers by setting the area of the rectangle equal to its height times width. So in this problem here we have then x minus 44.1 that's the width of this rectangle, times its height. So times its height, 1 over 16.1, has to be equal to its area. Its area happens to be 10% or 0.1. And we can solve this equation for x by multiplying first by both sides by 16.1. So we have x minus 44.1 equals 0.1 times 16.1. That's going to be 1.61. And then adding 44.1 to both sides. So that's 45.71. So that's x, and now we have to do the same for y. So here we have we can do this rectangle equal 10%, or we can do this rectangle, which is 90%. Either way, you get the same answer. So it doesn't really matter a whole lot. I'm going to do the big one, y minus 44.1 times 1 over 16.1 equals 90%, or 0.9, because I'm talking about this rectangle from here to here. Okay, and if we again solve this equation for y, then we have y minus 44.1 equals 0.9 times 16.1. That's going to be 14.49. And now we add 44.1 to both sides, and we end up with y equal to 58.59. And now let's take a second to remember what we just did. We were answering the question, what interval of height should the company expect to find the middle 80% of third graders? So these numbers here, these are the heights. We should expect 80% of fifth graders to be between 45.71 inches and 58.59 inches. So we can write the answer like so. Yeah, so the interval is between 45.71 inches and 58.59 inches. Okay, number 3. A salesman claims that 15% of third graders are at least 57 inches tall. Do you agree with the salesman's claim? Support your answer with a statistical reason. So our statistical reason will come from, again, drawing a sketch of the situation. We want to know what percentage of students are at least, now let's go back and see, at least 57 inches tall. So if we sketch in the graph and put 57 over here, approximately where it belongs, and then the percentage according to our distribution is the area of this rectangle here, and again the height is 1 over 16.1. So the actual percentage according to our distribution is width 60.2 minus 57 times 1 over 16.1, which is 3.2 over 16.1, or approximately 19.87%, 0.1987, or approximately 20%. So, and let's see what the salesman said. The salesman said 15% of third graders are at least 57 inches tall. Well, it's actually closer to 20%. So, I would disagree. More than 15%. I would disagree. I would disagree because it's more like 20%.